Just like when we did exponents and the properties of exponents were the same, the properties of the radicals are the same. Basically, what that means is if I have these two things that I'm multiplying under the radical, I can break them up. And it doesn't matter what that root is outside, as long as when I break them up, I keep that root the same. And we did this a lot when we were simplifying radicals. Remember how we had to break them up? We split them. Y'all remember? We're going to be doing the same thing today, but with different roots.
What?
So here, if the radical's the same here, if we're multiplying, excuse me, under the radical, we can split it up. And if we're dividing under the radical,
With a fraction?
we can split it up. Okay? So this goes back to what we said yesterday. If we're multiplying or dividing and the exponent's the same, we combine the base. And if the base is the same, we combine the exponents. Here, we can do the same thing as long as the base is the same. We can combine them under the same radical or split them up. So let's talk first about simplifying radicals. Y'all ready? Yeah. I think this is the hardest part of the lesson today, so we'll start with it. Simplifying radicals. All right, so we've done square roots a lot. Remember, if there's not a root there, it's an implied square root, right?
Yeah.
So when we simplified it, what did we do? We broke it down, okay? And one of these numbers that sit here had to be a perfect what? A perfect square. All right? So that perfect square is coming from, because remember this little imaginary 2 that sits here. And so when we were doing it, we had a list of perfect squares written out to the side of our paper when we started. And we picked the biggest one that would go in there, and that was 25 and 2. I'm going to tell you. So this is the same thing as the square root of 25 times 2. And we broke it up. Exactly. And we did the plus or minus 5 root too. But what if I changed, let's say I changed that root to a third root of 16.
Just use 2.
Well, now you got to think about powers of 3. 2 to the third, because I'm looking at this, that's why I'm doing powers of 3. 2 to the third is 8. 3 to the third is 27, and already that's too big. Can I divide it by 8? 8 times what? 8 times 2 is 16. Are y'all following what I'm doing? I'm doing the same thing that I was doing here, only it's with a third power now. What's the third root of 8? It's an odd root, so I don't need it. Right. Let's do another one.
Wait, hold on.
Okay. Let's try this one. This is going to be another third root, but then I'm going to up it to a different root. Let's do the third root of 135. See if you can figure this one out. If I'm asked to split it up and simplify it.
Well, come here, calculator.
Yep.
Come here.
All right, so a couple of you are saying 27.
It's a perfect cube.
45.
It's got to be a perfect
So it'll be 3 to the
Wouldn't it be 45?
Cube.
root of 5.
Wouldn't it be 45?
It's got to be a perfect cube, not something times 3, but it's got to be a perfect cube. So think about your cubes. 2 to the third is 8. 3 to the third is 27. 4 to the third is 64. 5 to the third is 125. Which of these, the biggest one, can you divide 135 by?
27.
27.
By 5.
Because 27 times 5 is the same thing as 135. Understanding that one of these two numbers must come from this list. Yes? So now, this is the cubed root of both of these. I can split it up by that property. And what's the cubed root of 27? 3. Do I need a plus or minus?
No.
Why?
Odd root.
It's an odd root.
What if you put a plus?
Then it's wrong.
Yeah, that's wrong.
See, now you got me all confused.
Oh my goodness.
If you have an even number as your root,
Brandon, you've never watched
Bro, I have
Oh, geez.
Try this one.
you're doing too much. You should really calm.
You said try a hard one.
Who said that?
It's really not that. Believe it or not, the bigger the root is, the easier the problem is. Because if you think about multiplying something by itself 6 times, you're talking about a low number. Exactly, Brandon. And you're definitely going to need a calculator for a lot of these.
Oh, wow.
Well, that is not work.
Wow. Yeah.
What's 3 to the 6th?
Yup.
So, right, you see what I'm saying? The bigger that root is, those numbers get real big real fast. So it's, well, does it work? 64 and 4.
And it'll end up being 2.
That's a 6 hole.
It's a 6.
No, 64, yeah. 2 to the 6th power. I'm looking at powers of 6. I forgot to finish right.
I guess you could say that's really good.
Quickly.
Positive or negative 2, 6 root 2.
I do need a plus or a minus here because it is an even root.
Why are you using 2?
Yeah, why can't you do it with 2?
What?
Wait, why is it a 4? I don't understand why it's a 4.
Because 64 times 4 equals 256.
Same, it's the same thought process. I'm, okay. No, it's got to be a 4.
Why are you using 2?
Where? Because 2 to the 6 is 64.
I know, but why?
All right, try to simplify this one on your own.
Getting out of school early?
All right, shh, 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 shh.
Man, that was good.
Dang.
I ain't got to do it again. Alright.
No, I can't believe it. That was a great explanation too, and I missed it. All right, do you see where we got the 8 and 13 now though? Okay, so we just worked our way up through that list till we got it, and then we got 13 left over. Now, I can break this apart as the cubed root of 8 and the cubed root of 13. And the cubed root of 8 is 2. Just understand, whatever this number is, that's what these exponents are here in my list. It's that 2 again. Most of the time, it's going to be 2 or 3.
Now you got a number like 1,000.
Because they just get so big so fast.
Wait, how'd you get the
Man,
2?
somebody's calling me.
Huh?
I get the right.
Feel it.
All right, hold on. What'd you say, Trey?
There's no exponent on the outside. You put, just leave it so you just 2. Shut up.
No exponent where? It's a 1. If there's no, you're talking about a root. If there's no number on the root, it's a 2, yes.
Wait, Miss Lee.
All right. Shh. That's the hardest part, in my opinion, with the radicals. We're going to use that, we're going to use that as we use the other properties as we move through, all right? So if we need to simplify something that looks like this, okay? When the roots are the same, again, and I'm multiplying or dividing. I should have put that first. Multiply or divide only. Yes, Brandon.
Oh, yeah.
Multiply. Or actually, I'm going to say combine inside. So if I'm dividing, I would be dividing.
It's me. It's got to be with me. Like it's
combine the inside. So here,
She knows.
no. Now, 12 times 18 is 216.
Are you working backwards?
This was the original problem. And because the roots are the same, I'm going to combine them under the same radical. Once I do that, then I want to try to simplify if I can. And this one's an easy simplify because what's the third root of 216? 6.
Word.
Word.
This one looks a little bit different. What do you notice, however? Because I am dividing.
No,
It's
it's
an
improper
improper
You can
fraction.
divide, you can, reduce 96 and 3.
Why? Why can you reduce those
Because they're both
though?
divisible by 3.
Not just that. They got the same root. If that wasn't the same, you couldn't do it. Okay, I want you to make sure you understand that. But because they're the same, I can look at it as the whole fraction under. That's that property we talked about in the beginning.
So 32.
So the fifth root of
32.
32. So now the question is, can I simplify that by doing this? Or is it a perfect fifth? Or is it already simplified?
Also, you divide 96 by 3?
2.
2 to the fifth exactly. So it's just 2. Does that make sense?
So 2 times 2 equals 4. 4 times 2 equals 8. 8 times 2 equals 16. 16 times 2 equals 5, 2.
We have talked about multiplying and dividing with radicals. And I want to talk about addition and subtraction of radicals for just a minute, and it's a little strange. But outside of that, we're not going to delve too much deeper into radicals. We've rationalized denominators before with square roots. We're not going to rationalize them with much bigger right now for lack of time. So we're going to look at the addition and subtraction real quick. And then I'll be done.
So, what is this? Why you adding new concepts? It's one concept a day. That's why you want this. That's why you want 40 years.
No, I'm excited.
All right. Let's think about something for just a minute.
You've already filled 11th grade. That's one.
Let's say I have
Okay, you got the same thing, so you just combine your radicals.
absolutely. You have to look at radicals just like you do when you look at variables, okay, and what we call like terms. These are what we call like radicals.
So 5 and 4/5, right? Well, not like.
But yeah. Like radicals have the same root and the same base under there. That's right. Okay? As long as those two things are the same, okay, to add or subtract them, you do just like you do when you combine like terms. So combining like radicals is the same thing as combining like terms. So, when I look at this, okay, 2 and 3 are the coefficients. When I combine like terms, I combine the coefficients. So here, this would be 5, and then I leave that radical alone.
Wait, what would that be?
That's 2 plus 3.
2 plus 3 gives me the 5.
Now, what if they weren't?
Wow, this is.
Okay,
That's what I was like.
what if they're not the same? That's a great question. Here's what we're going to do. If we set up to evaluate, okay, like this, and we notice, hey, wait, they're not the same root, or hey, wait, they're not the same base, okay? What we're going to do, I'm going to put not the same, oh, actually, wait, not,
No solution.
not like radicals. Well, then I'm going to check to see if I can simplify any. Now, when I say simplify a radical, tell me what I'm talking about.
Break it down.
Break it down.
Break it. Yeah.
For example, we'll actually make this minus since we haven't done a subtraction.
It's 2.
Are those like radicals?
Yeah, 8.
So you just combine them, you combine them.
No, those aren't like
When
radicals.
you take the threes and
No. You simplify.
They have like roots, but not like
Bases.
It's
bases.
gonna be 8 and 5. So it's 2.
So my question is, you're right, Darian. My question is, look at each one of them. Can I simplify that any? In other words, can I break it down? No, that one's as simple as it can get, right?
Yeah.
But the second one, I'm looking at threes, so I need to make that list of thirds. 2 to the third is 8, 3 to the third is 27, 4 to the third is 64. Can I divide by any of those numbers?
8.
The 8, right? 8 times what? So 40 can actually be broke down as 2 times the third root of 5. Do we agree?
And then you get a like base.
And the 3/5.
And all of a sudden,
Have like bases and like
I have like
And
radicals.
well, question.
Now,
Is that going to like to be a 1 in front of the
it absolutely is. Think about this like
So -1 and 3.
a variable. If you just have the variable there, Gil and Dwight, y'all have been so into those phones, y'all better make 100 on this quiz tomorrow. Think about these bases as variables, okay? If there is not a coefficient in front, then I can put a 1. So now when I combine coefficients, what is 1 minus 2? -1 times the cubed root of 5.
so if they don't come out to be the same, like terms.
176. I'm not feeling that.